everyone, in this video I'm going to be talking about what we call the slope-intercept form of the equation of a straight line. So this is part 2 of talking about linear equations and their diagrams. In part 1 I discussed the slope. And really the point here is that, algebraically the equation of a straight line is very often expressed and taught in this really canonical form that a lot of people learn about in high school. It's called the slope-intercept form of the equation of the line. So abstractly, if I had two axes, x and y, with y on the vertical and x on the horizontal, and if I had an equation which was in the following form, so y is equal to mx plus b, then the line of this equation would be a linear diagram. This is a linear equation, so we would get a straight line function. M, the coefficient on our x variable on the right hand side, that's equal to the slope of the line, and b, that's our y-axis intercept. That's where our line intercepts our vertical or our y-axis. So if m was positive, for instance, our line here might look something like this. We have b where it hits our y-axis, and the slope is equal to m. Now in practice, m and b will be some numbers, some real numbers, and x and y could be many different sorts of variables, so price and quantity, for instance. It also, I will say, it doesn't matter what order that you write the terms on the right-hand side of the equality. So we could write this as y is equal to b plus mx. B and m will still have the same interpretation here. And what's really important here is that it's y, that's our vertical axis variable, that is isolated on the left-hand side of the equality sign. And x, that's our horizontal axis variable that's on the right-hand side, is just hanging out there with at most a coefficient m next to it. So it's not raised to any power, it's not on a denominator, we're not thinking about the log of x, nothing like that. All of these things would imply a nonlinear or a curved line equation. Now, I will clarify though, if there is no actual number in front of x, that just implies that m is equal to 1. So we notate 1x as just x, right? And if there is no b, that just implies that b is equal to 0. So in that case, our y-axis intercept is 0, and in fact, it will go through the origin in that case. So let's go through an example to demonstrate, and I'll just keep it abstract. So I'll keep with the x and y variables for now. If we were given the following equation, y is equal to 4x plus 10. So maybe pause the video and try and draw it out. Well, b, our y-axis intercept, would be equal to 10, and the slope is equal to 4. So that means as x increases by 1, y increases by 4. To go through our other cases, if we just had y is equal to 4x, so the 10 drops out, so b is equal to 0, then our line would look like this. Our y-axis intercept would be equal to 0. The slope is still 4. If we had y is equal to x plus 10, so no coefficient is written in front of x, that just implies that m is equal to 1, and b is still equal to 10 here, so perhaps that line would look more like that. That's a slope of 1. And so our slope-intercept form is a really powerful form. It gives us a lot of information. We can basically just read the slope of the equation and the vertical axis intercept as well, and that gives us a way to draw our linear functions really easily. Now, I will say though, when we're presented with an equation, before we make any conclusions based on this form, we do have to check whether we are actually in the right form, because our equation might not always be in the right form, but it might look like it is. For instance, let's consider a demand equation Q is equal to 10 minus 2p. So here, instead of our variables x and y, we have price and quantity. And you might be tempted to think that the constant term 10 here, that might be like the price axis intercept, the vertical axis intercept, and -2, the coefficient on the price variable. You might be tempted to think that that's the slope. But just note that when we draw out our demand curve, it's price that's on the vertical axis and quantity is on the horizontal axis. So this equation is actually not in the slope-intercept form because quantity is on the left-hand side of the equality and not p. So 10 is not the vertical axis intercept and -2 is not the slope. We would need price on the left-hand side for it to be in the right form. So I encounter students making this mistake all of the time, and it's really sad when I see this on exams because students end up losing a lot of marks as a result. We can put it in the right form though. We would just need to manipulate our equation until price is on the left-hand side of the equality. So we could add 2p to both sides and then take away q from both sides. And if we divide by 2, then I get my equation p is equal to 5 minus q over 2. So in fact here, that's in the right form. Our price axis intercept is equal to that constant. It is equal to 5, and our slope is equal to -0.5. That is the coefficient on the quantity variable, the horizontal axis variable. So if we drew that on our diagram, maybe it would look something like this. Now it is worth noting here that all of these equations all identify and describe the same line. There are many ways to algebraically describe this line, but for us to be able to read the slope and the vertical axis intercept off the equation, we just need to make sure that it's the price variable on the left-hand side. That's what puts it in the slope intercept form. Price is like our y variable. And just to link this to some of the things that I was talking about earlier in this course, in our function notation, this first form would be quantity modeled as a function of price. In the last equation, it would be price modeled as a function of quantity. Now, in terms of drawing out these lines, on our diagram here, I've labeled our price axis intercept and our slope, and I've labeled the axes, and I've also put in D for demand there. And I've also tried to be kind of to scale. I've made a little bit of an effort at least. I have known some teachers to not award full marks for diagrams if it's clear that the student didn't make any effort to be to scale, or if they're just really out of scale. Your teacher also might need you to isolate all of the axes intercepts, so this one as well. You can find this intercept by setting price is equal to 0 in our equation, any one of our equations, and then solving for quantity. I will discuss our intercepts a little bit more in the next video. Your teacher might have other requirements that are important for them, so maybe labeling the origin, what they consider a well-labeled diagram to make sure you get full marks. You should check with your teacher if you're not sure, because you don't want to lose marks on this sort of stuff. It's not a great place to lose marks. So in the next video though, I will go through another way to draw out linear diagrams from linear equations, and I'll also discuss the cases where we have perfectly horizontal and perfectly vertical lines. I think that's enough for this video though. As always, thanks so much for watching my content. I hope that you're enjoying the course if you are watching all of the videos. If you would like written notes to help you on your journey, or even just to support this channel to help me make more videos, you can visit my store. The notes associated with this course on basic math skills for economic students includes lots of questions and solutions which can help solidify your understanding of the skills discussed in these videos. Also, if these videos have helped, please like and subscribe, comment below, share, all of that. It all helps. Any feedback is super welcome. Thank you so much for watching my stuff, guys. Have a great day, everyone.